All right, in this example, we're going to do an exponential growth problem. So the rate of change of the number of people infected by coronavirus is proportional to the number of people that have coronavirus. Sorry if it's too soon for this example, given that we're probably all sitting in social distancing mode right now. If 3 people have it at t equals 0 weeks and 30 people have it at t equals 2 weeks, write an equation that models I of t, the number of people infected after t weeks, right? All right, so the first thing we need to do is recognize that this phrase right here, so the rate of change of the people infected by coronavirus is proportional to the number of people that have coronavirus. That right there says, oh, hey, I'm looking at di, because instead of y, I used I for the infected, dt equals ki, where I is the infected. It's not cheating if, as we discussed in the last video, you know that this integrates to what we said was y equals c e to the kt, or in this case, it would be I of t, because that's my y value, equals some constant c e to the kt. Nobody thinks that that's cheating. So again, it's also not cheating to recognize, as we discussed in the last video, that this c is always going to be your initial value, which in this problem was given as the 3 people that have it at the beginning of the problem, right? 3 people. So it's also not cheating to make the mental leap that that c is 3. But if you need to, you can plug in that I of 0 is c e to the 0, and that's I of 0 is 3 people. So sure enough, c is 3. So without actually doing all of the integration work, we now have that I of t is c, which was 3, e to the kt. I'm then going to have to use the other point I was given, right? So I was given this other point that there are 30 people after 2 weeks, right? I'm going to have to use that 30 people after 2 weeks to find k. So I know that when t is 2, I is apparently 30. So if this is a non-calculator section, you're going to get answers that involve some natural logs, and that's fine. If it's a calculator section, sorry, there's my calculator, you would be able to plug this in and get numerical values. But again, I'm going to proceed as though this is not a calculator section. If it was a calculator section, or rather if it were a calculator section, then you'd be able to plug in and get a numerical value for k. So I'm going to plug in 30 equals 3 e to the 2k, and I'm going to solve for k. So I divide both sides by 3, right, because we use SADMAP when we're solving, so there was no subtraction and addition, but there was division and multiplication. So I get 10 equals e to the 2k. I then deal with the exponent by doing a natural log to both sides, so the natural log of 10 equals 2k. So I get a 1/2 times the natural log of 10 as my k, which means that that whole ugly mess is going to be my k in my final answer. So my final answer in this problem is that I of t is 3 e to the, and then I'm just going to put my k in parentheses to make it clear that the t is not inside the natural log. So I get I of t equals 3 e to the, and then my k was a 1/2 natural log of 10, all in parentheses, times t, and that is my final equation. Sometimes you'll be asked to use it, but sometimes you're just asked for the equation.